Hey everybody, this is Larry. This is me doing the daily challenge, day 28. Hit the like button, hit the subscribe button, join me on Discord. Let me know what you think about today's problem. 1547. Minimum cost to cut a steak. I'm here in Armenia, so yeah, hopefully doing more drone stuff. But definitely hit the follow button on Instagram as well if you were curious about my travels. Yeah. Anyway, today's problem is 1547, minimum cost to cut a stick. So given a stick of n units, the label is 0 to n. For example, you have 6, okay. Cut to by is where you should perform a cut. So you give all these cuts, and what's n? N is the length of the stick. And then there's a cost, I guess, and you have to minimize the cost. So this is probably going to be dynamic programming. N is 10 to the 6. But the number of cuts is only 100, so we probably want to do this in the order of number of cuts. Yeah, and of course, the first thing you should do for some reason is that cuts is not sorted. So let's cut sorted, and then okay. So the cost of one cut is the length of the stick, right? So okay, what does that mean? So that means that if we cut so that means that initially it's going to cost the entire thing. Yeah, okay. So basically, yeah, it's just dynamic programming. The idea is that, okay, you have the left index and the right index, and then you just do cuts based on that, right? Yeah, and basically every time yeah, every time you cut something, you kind of just want to limit you want to limit the things that are in the next thing. Man, I'm not saying that right. You want to limit the search that you're gonna do. Though maybe it doesn't even matter that much. Maybe it's just a minor thing, because I don't think it adds a maybe it adds factor. I don't know. But in any case, yeah. So the way that we're gonna set it up is that, okay, let's say I'm gonna rename this L. So L is equal to the length of the thing, N is equal to the length of the cuts, and what we want to do, what I want to do anyway, is actually maybe before we sort, we append 0 and we append L. That way now it's not just the cuts, it also represents the edges of which we care about. So that, I assume they're not going to give us 0 and L, but so that it, yeah, the edges, right? Because once you cut, you're always going to be on one of the edges anyway, right? So yeah. So then now what we want to do is we want to calculate the min cut for then now a subsection. So that means that we want a substring thing. So we do left, right, and as we always do, as I always try to do, though during the contest I'm a little bit sloppy for sure, is that we want inclusive bounds, right? Or like, well, that's not necessarily what you want to do, but what you should do, what you want to do is define the left and the right? So for me, this function is left and right are the edges, or technically cuts of left and right, but okay, fine, right? Are the edges of the current stick to cut inclusive, right? And this kind of gives us a very cool way of doing it, because if left is greater than equal to right, there should be only just equal. That means that our stick, we return 0 because that's the length of that stick is 0 for whatever reason. Or even, which is fine as a base case, but it's not the best base case, right? The base case is actually if left plus 1 is equal to right, then we return 0 as well. So we can actually just put it up here as well. The reason is because now you have a stick that you're not going to cut anymore, so you don't have to measure the cost of the stick, right? And then now the way now that we set it up is that now we can cut along this thing, right? So the cost is always going to be the same. So, or I believe, unless I'm misunderstanding this, it's going to be cuts of right minus cuts of left, because that's the length of the thing, right? The length of the stick. So then now for I, we want to start with left plus 1, and we want to go up to right in Python notation, just exclusive, right? Because you can't cut on the left edge or the right edge, like that or it means that you cut a 0 piece or whatever for whatever reason, right? So anyway, okay, so yeah, so then now we have a best is equal to minimize, right? To minimize, we set an infinity value. So then best, we min best, and we calculate min cut of from I is now the left side. Well, okay, there are two, now there you have two pieces really. You have left to I inclusive plus plus I to right inclusive plus cost, right? So I guess you could always factor in cost later, it's the same. But yeah, and that's pretty much it, I believe. So we can return comment 0 and n, except for I lied, because this 0 has to be the n, or the n has to be the n that after you added the two things. So let's give it a spin. Oh, this is n minus 1, obviously. I am just being silly. Okay, so this looks good. Of course, I mean, this is the dim all week, or at least all week being the last couple of days, is the bounds has to be, or we have to memorize it. Sorry, oh man, I'm so out of shape. Yeah, so we have to memorize the bounds. So yeah, so basically what we want to write, and I'm teaching this maybe a little bit differently than usual, but the short idea here is that left can go from 0 to n, right could go from 0 to n. So and we want to write something like if has cache of left right, return cache of left right, and then at the very end we go has cache left right is equal to true, cache of left right is equal to best. We set cache. Of course we have to just define it, right? So has cache is equal to I always do, and then same thing, right? And yeah, and now we can give it a spin. Let's give it a submit then. Hopefully, yep. And that's pretty much it. Long day streak. I was just checking whether whether I was recording correctly. Though at the very end it's probably too late for that. But in any case, yeah. So what's the complexity here, right? The number of inputs is 0 to n squared, right? Each input takes O of n time, so total time is equal to O of n cubed, and total space is going to be n of n squared because each input takes O of 1 time. Oh, sorry, space. Yeah. There's also an n log n component, but obviously n, yeah, it gets dominated by n cubed, so that's going to be the complexity ultimately. Cool. That's all I have for this one. Let me know what you think. Stay good, stay healthy, to good mental health. I'll see y'all later and take care. Bye bye.